Hi, my name is Claudia, and today I'm presenting my open source data project, for which I used Power BI to create this dashboard on mosquito insecticide resistance. To guide me through this project, I used the AWESOME framework, which stands for Obtain, Scrub, Explore, Model, and Interpret. I framed a definitive set of questions which guided the information I would include on the dashboard to be able to extract meaningful results. Malaria kills, on average, 400,000 people every year. Currently, the two main methods for vector control are house spraying and insecticidal nets. However, an alarming rate of vector resistance to these insecticides is causing a resurgence in malaria cases. Developing a new class of insecticides takes 12 to 15 years and costs over $250 million. Therefore, it's critical to build localized resistance profiles and tailored plans to tackle the spread of resistance using the current insecticides we have available at present. I got my dataset from the World Health Organization, and I selected 4 main datasets to provide a comprehensive overview of the significant issue of mosquito insecticide resistance. The first 2 datasets provide resistance status, and the other 2 explore the mechanisms underlying resistance. Since I am working with Mac OS, I used a Microsoft Azure virtual machine to run Power BI on. I downloaded the data onto the machine and loaded it into Power BI. I then created a data dictionary to improve overall data understanding. The questions I wanted to answer were about the spread of resistance over time, what molecular mechanisms are behind resistance, what areas are likely to be affected in the future, and if there are any specific regions needing urgent attention. To scrub the data in Power BI, I opened Power Query Editor and removed unneeded columns like country codes, area codes, and citations. I also checked for missing values and filtered these out. I needed to replace a lot of values for the mosquito number columns, which included some estimates. I replaced each with the average value and deleted any rows where the study had less than 15 mosquitoes. Another example of error handling was finding a wrong data point when I made a scatter plot of longitude and latitude against mortality. I used a location calculator on Google to find the correct data point and replaced it in Power Query Editor. Comparing average, maximum, and minimum values provides a general overview of the data. I realized that the intensity concentration bioassay table was quite limited when compared to the discriminating concentration bioassay table, in terms of unique country and species count, as well as the period of time the data was gathered over. I used Power Query Editor's data profiling function to display more information about the columns, like quality, profiling, and distribution, which showed that 30% of the data points were not available for resistance intensity. Instead of discarding this table and these data points, I appended certain rows from it onto the discriminating concentration table. First, I filtered the insecticide concentration column to match the strength in the discriminating table. I then made sure all columns had the same name and data type and then appended them before deleting any duplicates. This added around 700 more studies onto my first table, effectively enriching my dataset. For the rows showing not available, I was able to impute the data by using DAX to create a conditional column based on mortality adjusted. I also used quick measures to create a graph that was clearer to understand at a glance. The first graph was misleading as it looked like there was a decrease in confirmed resistance. However, using the running total of studies showed an increase in this trend. So finally, I'll talk you through my dashboard. On the left-hand side is a field map showing an overview of the distribution of resistance across the globe. As this dataset contains local information as well as country name, we can drill down in this hierarchy to display resistance by region, which is important when designing localized plans to tackle spread of resistance. You can also use the legend to filter by resistance status: confirmed, possible, and susceptible, meaning the mosquitoes are still sensitive to the insecticide. Underneath is a slider to display how resistance changes over time. Displaying a map and timeline make it easier for the user to see areas of merging resistance. Resistance has spread rapidly since 2007, highlighting the urgent need for alternative vector control. The graph underneath shows the total number of registered cases over time to emphasize this point. On the right-hand side is a multi-row card displaying the top 5 mosquito species from whatever filters are on the page. For example, if you select confirmed resistance on the map, you can see that 58% of the Anopheles gambier mosquitoes make up that resistance. The pie chart displays the percentage of insecticides that mosquitoes are resistant to, by class and type. Pyrethroids are the class most mosquitoes are resistant to, which is a major problem since they are the only insecticide deemed safe enough for use in treated nets. And finally, mechanisms of resistance. Insecticides work by binding to specific sites in the nervous system and causing paralysis. Mutations in these target sites prevent insecticides from binding, leading to resistance. The second mechanism of resistance is how quickly insecticides are metabolized. Upregulation of cytochrome P450, esterases, and GSTs all lead to resistance to different classes of insecticides, as detailed in the mechanism mapping table. To conclude, this dashboard can be used to design localized resistance profiles and unique plans of actions to tackle the spread of resistance. I designed this dashboard to tell a story of the spread of resistance, which answers the key questions I asked at the beginning of this project. One question I was unfortunately unable to answer was predicting which geographic areas are likely to see an increase in resistance. In future projects, I would like to incorporate a regression analysis of the data using Python. Thank you for listening.